Good day, everyone, and thank you for joining this webinar on Reaxys structure searching. I'm the host for today, Kim Gordon, and I'm here with the presenter, Derek Imali, a customer consultant with Elsevier. A few things you'll need to know. During this webinar, you may send us your questions using the Ask a Question feature on your control panel, and we will answer them via email. After the webinar, you'll get a short survey. Please fill that out as it helps us develop future topics. All lines are automatically muted since this is a recorded session. And again, if you have any questions or need to contact us during the webinar, please use your Ask a Question feature. And Derek, I'll turn it over to you.
Thanks, Kim. Hi, my name's Derek, and Kim, the recording is on, right? Just want to make sure. So thank you. This is an introduction to the new Reaxys. What I want to get across today, and what we've been seeing on feedback. So thank you for the folks that have been providing feedback as they're using the interface. Is the use of the structure editor. We're getting a lot of questions on the structure editor. So this is a good time to do a review on going to Marvin JS. So that's what I hope what we're going to cover today mostly. So as Kim had mentioned, there is a question feature in your GoToWebinar. Submit your questions on there. If they're simple enough at the end of the session, I'll try to answer them. And then after the webinar, we'll get a list of the questions, and I'll reply personally to all the questions there. So feel free to submit those questions, and we'll get back to you as soon as possible after the webinar. It'd be interesting to see a lot of your questions. So why this new Reaxys? You know, just a brief history of Reaxys and what it's been built on, right? Going back to 1817, the Gamaliel Handbook, first edition of the Beilstein Handbook in 1881. So this literature, if you're in chemistry, you know, a while back, a lot of that was having to learn German to be a chemist and having to go through the Beilstein handbooks, appreciating some of that. You can see here in around 1989, 1990, there was an initiative to get the Beilstein and Gamaliel databases to go online, appearing on STN and Dialog. Crossfires launched in 1993. And then we go to Reaxys. A little bit about me, I forgot to say this. I've been with Elsevier now for 15 years. My name is Derek Imali. Been with this product since early 2000s. Started my career at MDL supporting chem informatics, bioinformatics solutions. So having a lot of experience on showing chemists and folks how to search these databases. So a little bit also around 2007, we launched what was the Reaxys, and going around with the product manager, it sort of brings it back full circle. We've got even a newer interface. And why are we doing this? A lot of folks like the interface of the old Reaxys. A lot of usability, a lot of resources, a lot of thinking went into this streamlining of the user interface, right? We found that a lot of that complexity of the Reaxys interface, it hides a lot of the benefit, right? A lot of the excerpted data getting to the indexing. So the product team tasked itself with creating a more intuitive, cleaner layout to make it easier to use, right? More folks going in there, using it, providing the benefit that the data that we're providing, the data that we're going to provide in the future, the amount of data that's going to go in there is going to be easily exposed to the user when they've got a cleaner interface. They don't have to spend as much time learning an interface. So what's new, if you are looking at the new Reaxys, it's a new URL. Sometime in mid-2017, we believe we can switch most of the folks to this new interface. We understand that takes time, right? Convincing a pretty established user base that this newer interface is going to provide more benefit. So really, the landing page is new. Marvin JS structure editor. This is something we really thought about, and it's really an initiative with with you know, things that we're seeing from like Google or even the modern browsers, getting away from the Java-based applications, right? So this is Marvin JavaScript, so really getting away from that Java-based application, more embedded directly into your browser, providing you quicker access, more seamless, less buggy interface to drawing tools. You'll also see in the old interface, we've changed the standard structure search, right? It used to be to not, you had to actually select not to include certain things. So it's easier. Let me just switch on over to really quickly what I'm talking about with this change. So as folks migrate to a newer interface, oftentimes they do a search in the old interface and then compare it to the newer interface and say, hey, you know what, the numbers are wrong. I'm not getting the same search. So a couple things around that. The database in the new Reaxys versus the old Reaxys, the underlying data is a bit different. They're updated on a different cycle. Sometime in, I think, the December or January timeframe, both of these databases are going to be pulling their data from one single database. So that's one reason why you might see differing numbers. The other that I brought up in that PowerPoint, you see here, if you draw a structure in this old Reaxys and then send that off, you actually have to make a selection to not include salts, not include mixtures, not include isotopes. So the product team in the new Reaxys actually made a conscious decision to make it more of an exact search. So you draw your structure. If you want to include salt mixtures, you actually have to make the choice there, or isotopes, charges. So that could be a difference in the number that you're seeing. So you'll also see in the new Reaxys, we've updated a results preview, a lot of filters and analysis, a lot of index terms. You're going to hear a lot about the content we're adding, and really these index terms are there to provide you clues on how to do a better search, the content of the result that you're seeing. So a lot of new things happening in Reaxys. A lot of what's driving this is usability studies. We've studied where folks go in the old Reaxys and trying to clean that interface, so what is most used is what's most prevalent in the new Reaxys. So with that said, again, pose your questions. I see some questions great coming in. I'll have to expand that to look. We'll answer that at the end. Tips and tricks on Marvin Sketch.js, right? So that's what we hope. And really, I was thinking about this. I don't think, and I don't know if this is good or bad, anyone has done any more demos or more trainings on Reaxys Crossfire than myself in actually the world. Now that I think about it, I've been doing this since, like I said, 2001. So that's a lot of web access, a lot of trainings, a lot of interviewing customers, talking with chemists, and then seeing what they do. And it's funny, when we do these trainings, I've given the training. I don't know if that's just it's not driving home the point, or people forget because they're not in the tool a lot. I often have to do things such as showing atom list or where things are to do a better structure search. So really what I want to do is, from experience, what most folks do, right, which is just draw a structure and they want to do a simple substructure search. And from there we'll expand, right? The hope of this is, hey, I saw that in that demo, and there are things in there that I can apply. Let me search. So it's really giving you the initiative, I thought I saw that, let me look for that and explore and find resources to further my structure searching. So the things I'm even showing you today don't apply just to Reaxys searching. The things I'm going to show you will apply to many of your own structure searching on other databases. So remember these concepts. They will work across Marvin JS. So again, hopefully that'll provide some benefit as well, not necessarily just a Reaxys benefit here. We're going to provide the PowerPoints after this. So one of the things that that's in the PowerPoint are great places to start, right? So the user guide, keyboard shortcuts. So you'll see me do some of these things. I'd start at the user guides, keyboard shortcuts, and then maybe explore some of the more powerful things. I kid here. a lot of folks now, the newer generation, millennial generation, like to learn things via YouTube, right? So ChemAxon, who we partnered with to put Marvin JS, provided some great video tutorials. I find that that's actually easier, spending 3 minutes on a YouTube video to learn something. I find myself doing that as well. So Marvin JS, ChemAxon has provided a lot of great resources. Hopefully in the future we'll be able to bring them in on a webinar, and we can show you some more advanced searching structure topics in there. So let's go ahead and go into some general Marvin. Yes, so George, thanks. We'll give these presentation slides after this. So some general Marvin JS tips, right? I'm in Marvin JS right now. If you start in Reaxys, we come in here. You're going to create a structure and reaction drawing. One of the main tips, you might have a smaller laptop, a lot of keyboard shortcuts, F11, a lot of browsers support that, expanding it to full screen. F11 brings it back down again, so F11 will help give you more screen real estate. Appreciate that. And some things, just navigation, right? We'll start left to right. We're going to talk a little bit about atom lists. A lot of chemists always, hey, I want to turn an atom into a carbon, nitrogen, oxygen, right? Create that atom list, carbon, nitrogen, oxygen, put that, and then a certain atom can be those particular atoms. You can also do a not list, right? So not those atoms. So a lot of the atom properties in Marvin Sketch, if you look to the top, more of your sort of saving opening. This is one I'm going to point out when we do substructure searching, is the add explicit hydrogen. You'll see the more common tools here, your eraser tool. So a keyboard shortcut, if you find yourself navigating to some of these tools and want to get there, use your escape key. That will bring you back up to sort of that more pronounced selection tool, right? Whether you're selecting a structure via just the square selection tool, or you want to freehand draw right here. So if you've selected something and don't want to necessarily move with the mouse, hit escape. It'll bring you right back up to what you most commonly use your mouse tool for. So let's go ahead and let me flip back to the PowerPoint, zooming in and out of structure. So we're going to talk a little bit about these. Oh, the other thing, copying and copy and paste from other editors. So a lot of this talk don't necessarily need to do Marvin Sketch. You can use your drawing tool. So if you like using ChemDraw, I've got here Meprazole. I went to structure, convert name to structure, typed in the Meprazole. You can copy and paste from your favorite drawing tool straight into Marvin Sketch. So you can draw as much as you want in other drawing tools. The trick to copying and pasting from another drawing tool into Marvin Sketch really is not to use the Control-C. What you want to do is copy as. And they do give you shortcuts. You want to either copy as a smiles or a Moltex, right? So smiles, Moltex, and then there's a shortcut there, Alt Control-C. Get used to that. So I've copied this structure. And if I wanted to bring that Omeprazole to Marvin Sketch, select in there, and then just Control-V, pop it right in there. So again, hey, if you like using ChemDraw, you like drawing on that tool, no need to use a Marvin Sketch and learn a new drawing tool. Draw what you want in your tool, and then and copy and paste. The trick is copy as smiles. The other thing that I had to get used to, right, coming from a Marvin Java-based app, was moving a compound around. It was frustrating because I was floating the mouse over an empty space and then moving it. That's what I'm used to. When you want to move a structure in the Marvin JS sort of drawing tool, you'll notice you have to float over an atom or a bond, and then you can drag that, move that around, right? So getting away from selecting an empty sort of place in the box and then moving that around, selecting some place in the compound to drag that around there for you is a good trick there. So yeah, let's put that in there again. The other thing I wanted to show you, if you've got a mouse that has a scroll wheel, just use that scroll wheel to move up and down. That'll zoom out your structure instead of going to the keyboard command to zoom in and zoom out. A lot of folks have a mouse with a scroll wheel. Try that out, and then you'll see that it's a nice little shortcut to zoom in and out of a particular structure. So a lot of things, and then if you noticed in my links, there's a user guide and the keyboard shortcuts. Learn those keyboard shortcuts. That's what I'm trying to talk to you about. So let's go. We did some of these things, moving a structure, zooming in and out, getting around the canvas, some general ones. When I was learning this tool, I would have appreciated, instead of just moving that structure, took me a little while to get used to. So one of let me come back here. Things I want to relay to you are substructure versus substitution count versus position variation bond. 80% of what you're going to be doing in structure searching is going to revolve around this substructure type search, right, and giving you pointers on that. And then if you prefer, you can use substitution count, right? Really, hey, how do we open up these two places on an indole compound to open it for substitution? How do we open it doing substitution count? And then we'll talk about position variation bond as another example that you can do in Marvin Sketch. So I'm going to go ahead and create a structure from template. I'm going to type in indole here. Brings me a base compound to work with. So what I used to see, right, our folks do this to do substructure search. They would draw a lot of these bonds and then get hydrogen and then draw it and put it all in there, really to block the substitution. There's a much easier way for you to do that. A lot of drawing tools have this. It's called add explicit hydrogen, add or remove explicit hydrogens, right? We can select that. It'll draw your explicit hydrogens. You have your eraser tool, delete where you want to add, maybe here and here, and send that over as a substructure. We can transfer that to the query and search. So that's substructure searching. Really, the point of that is using the add explicit hydrogens. You might have a complicated compound and you have to draw, I've seen chemists do this, draw all the hydrogens that they could possibly draw on certain positions, and then release. So you can see that here, just previewing the first three. If we clicked on the view results, you'd see that, drawing all those hydrogens. So that's one way to do that, substructure searching. That's one technique that is very helpful, and that's how you can do it in Marvin Sketch. And again, it's really being able to add the explicit hydrogens and then as substructure. The other one you might want to do is what's called substitution count. You right-click, atom properties, you go to the advanced. This is a lot of clicking. I'm going to show you a keyboard shortcut that I found a lot easier. You then have to go to substitutions exactly, and then put in 6. A lot of steps, a training effort here that was a lot easier in Marvin Sketch, but we're going to show you an easier way to do that, right? So 6, you could have selected multiple ones here to do the same thing. So as a review, advanced, substitution, exactly 6. So that number 6, if is really what it really says is at this carbon position, allow up to 6 non-hydrogen substituents, right? We have 1, 2, and then a third one there. Carbon has, can allow up to 4. If you wanted to be more exact with your chemistry, you might want to do S4. But in most organic chemistry, organic chem examples, 6 is a good number, S6. I'm going to go ahead and choose the carbon right there, and then that can delete that. Another way for you to do that, keyboard shortcuts. So if I press on the keyboard the plus, you'll see that period S star. Really, then we can just float and then just select on that atom, and it's floating that my substitution count. And then most of the times you're only actually selecting a couple atoms to do the substitution count. So what I did again was on the keyboard, press the period, brings up my atom query properties. Here's the plus substitution. I select that. It floats it on my mouse, and I can select places where I can then vary that substitution count. So if I transfer that as drawn, oftentimes I see people do this as drawn, then put substructure. That confuses what you're trying to do. So you either want to do a substructure search or draw it in this format and as drawn, and we're going to transfer that query and then search. So it sort of achieves the same thing. There's some variables in the numbers. I think this is the last structure retrieved 73, 192,073 versus 192. So there's some differences within that, but most of the times it's spot on. They're being able to do the substructure, opening it with the hydrogens versus the other way around. So how are we doing on time? Well, 10 minutes. So that's what we wanted to show you there with the substitution count. Let me know if you've got any questions on that. The other one I want to show you is position variation bond. And again, a lot of this is in the help files. I'm going to use my freehand selection tool, select this part, right? And then position variation bond is in our bond tool. We see it right here, position variation bond. And then maybe I want to select an atom list here, position bunch of different halogens, atom lists, halogens, floater right there. So what I just did there was at these positions allow a halogen to be placed at any of these positions, right? So that's one way to do these searches as well. And we can send that off. You'll see preview our results, just what we expected, sort of that halogen floating around at those different positions. If we looked at all the results, it's only at one position, but if we looked at the full result set, you'll see it does float in different positions. You'll see the shopping cart. So again, this is a little bit of our structure searching, really getting in there and giving you tips and tricks on Marvin sketch there. One other one I'd like to show you, which I didn't point out in the beginning, a couple things here, is abbreviated groups right here. This is another good way to draw structure. So if you're like a group and you don't want to draw that protecting group, right, I can actually come in here. Let's put in a tosylate group there. I'm going to expand it. You can see that it's drawn for me, and then I can drop that there and use that. So again, a lot of different groups that you can use, expand it, have that drawn easily for you. So using the sort of the abbreviated groups as a good way to ease your drawing in Marvin Sketch. A lot of folks appreciate that when we show that. I forgot to show you one other thing, the any bond, keyboard shortcut. If we look at bonds, if I'm on the keyboard, I can actually type in 2, 3, double bond, triple bond. The one that a lot of folks like is this any bond. So I just use the keyboard, got any bond there. Just want to put this out there. A lot of folks sometimes, you know, where's the double bond? Where's the single bond? I've drawn this compound. I can clean it up with the clean tool if I'm a little OCD on that. And so I use the any bond because this could be a single, double bond. We don't know quite where some of these items are. I just use keyboard on the shortcut 0. You can see it gives you the sort of the keyboard shortcut that you might want to use on there. Does the same for nope. Any, if I transfer that, you'll see that this any bond works really nicely too. So if I view the results, you'll see things that might be helpful for you as you draw these kinds of compounds that have sort of a you have a undefined way that the bond structure, the bond, double bond, single bond are drawn. So, whoa, we are now down to 5 minutes. We're going to now apply some of what we've learned to the workflows out there. So, again, I don't know if I pointed this out. As you're drawing structures, as you're using new Reaxys, a couple things. On the right-hand side, feedback. If you see a bug, you like something, that's always good. We like to hear about that. The product team likes to hear what we're doing well. If you're struggling with the new Reaxys, here's a link to the old Reaxys is down below the help file. Also right there, clicking on the help file, I'm going to click on F11. It's going to bring us to the Reaxys support, and you're going to see workflows here, right? And then the one workflow that we're going to apply is a search for substances, search for reactions when you're getting started on that. So one of the things that we're going to go over right now in our presentation is a workflow, right? Applying what we've learned, right? We're interested in a substituted sulfocoumarin, and we'll walk you through this example and really applying some of those things I've showed you, tips and tricks on getting around new Reaxys, particular Marvin's JS, which I appreciate. Having to learn a new drawing tool can sometimes be just, hey, why do I want to spend? So I'm going to structure from name. Put that out there. Reaxys draws that for me. I then want to select the double bond tool. I've learned the double bond tool. I just hit the 2 will give me a double bond. I'm going to place a double bond here on my atom property. I'm going to select oxygen there. Oops. Sulfur here. Drawing sort of our base template here. Now we're going to use our bond properties. We're going to change these to any bonds, right? Freehand selection tool. And select it there, complete that, and then change that to any bond. There, or if you wanted to, if you like using right-clicking on the mouse, bond properties, any, some other choices there too in ring and chain. If you so were so inclined to do that. We learned how to use a position variation bond, right? So let's do the selection tool again. We're going to select here. As a summary, we know to come here for the position variation bond, and in this case, we're going to choose the Reaxys generics. Right, the Reaxys generics are noted here. We're going to choose the. So this is just to explain a little bit about the Reaxys generics, acyclic. As you go down the tree, it gets more specific. Cyclic is here again, and then some of the short terminology. This is a heteroaryl. This is heteroaryl with a hydrogen. So the same choice, but with a hydrogen. The same choice with a hydrogen. And in this case, I think we just wanted to do a group generic and apply that there. So any generic group can be put on there. We want to then also apply our substitution count. We learned that if we press the period, we can select the S plus, and that will get us to our S6 up to 6 non-hydrogen substituents there instead of using our keyboard shortcut, and then we can go ahead as drawn. Try not to mix that. If I've seen folks do this and then do substructure search and then try and wonder what they're seeing, that's always something that they'll have to run into. So 123 compounds. If we view the results, we would then see sort of what we've drawn there, right? The position variation bond going around, substitution defined at those 2 positions there. We're seeing that, which is really nice. So that's a good way to end that. If you look at that workflow, we then post-process that using some of the functional group classifications here. So that's a good way to further take these 123 results, and then maybe you want to see the ones that have various different functional groups, and you can see how that would work using the functional group classification filter. And the workflow will step you through that. That brings us to 30 minutes. I'm one for sticking to the time that we allotted to the WebEx. Some questions, feel free to send that off, and I hope what we did show you was really giving you the techniques, the tips and tricks the differences between Reaxys, new Reaxys, where to go for that Marvin JS documentation and videos, some tips and tricks to get you started, some more advanced concepts. Hey, you know what, I can expand my searching capability. Where would I need to go for that? And then really a lot of what you probably do are the differences between substructure substitution count. Pick a way that you like to do that and how maybe position variation can apply. And then we took what we learned, what we showed you, and applied that to a structure search workflow that we can find in the help. And then if you were to go through that, it would further do some post-processing, analyzing those results to help you further filter the hit set that we got. So that brings us to 30 minutes. I've got some questions here, creating more current Reaxys video YouTubes to show the new students. Yeah, we have that on the agenda. That was what we were talking about earlier this morning, is 3 5-minute videos, really pointed topics, how to search for polymers in Reaxys. Thank you for the comment on getting rid of Java. Yes, yes. And then I think we talked about ChemDraw, for example. The old Reaxys actually had the ChemDraw supported structure editor. You had to download plugins. I showed how to copy and paste from ChemDraw. That's where we're at now. We're going to give some presentation slides. And then the other question, Nuria is saying, I don't understand the use of substitution count. A carbon can only have 4 different substituents. Why do you set S6? So I talked about that. Most organic chem, you're right, Nuria. A carbon, to be chemistry correct, you should put S4. So you're absolutely correct. It's shorthand, and it comes from actually back in the old days when they were trying to sort of create shorthand searches, substitution count. It was just became one of those things. S6 can stand for most organic chemistry reactions, substructure searching. Notice I say organic. If you were to search, and you would want to do a much higher count if you wanted to try and do that same thing with metallic. If you were doing some more inorganic type searching, it'd be very different. So the other substitution count, we saw you stepping up from 0 to 6, but I do not think you said what you did to. So what I did there was actually, you know what, I didn't say that, which is, thank you for bringing that up. I just clicked on the mouse. So once you bring period on the keyboard, period, you'll pick the S plus, and if you just click on your mouse, it'll step it up, and then it'll step up the count for you there. Right, or if you wanted to, you can just do atom properties, go to advanced. Substitution is exactly 6. That is a training effort that we're going to have to look at for folks. So thank you, Nuria. Great, thanks. I'm glad you like the upgrade, and spacebar works. Ah, great. Teresa, my fellow customer consultant, spacebar actually does the same with the substitution count. So George, We'll send you some, the thing with the substructure and substitution count, it's best to play with it. So I think a lot of times if you come here and then set this to you cycle through and say S4 and then S6, you'll see sort of the differences, right? This one, if you sort of play around with that substitution count and do some just simple structures and then step through there, you'll see exactly what we mean by what the substitution count means by up to that many non-hydrogen substituents, right? So you'll see that. And again, when I go out I show this substitution count, but a lot of folks just go straight back to the add explicit hydrogen and do substructure searching. That substitution count can also be used to block substitution as well. You'll see different nomenclature for blocking substitution with that same technique. But yeah, I think that's a training issue. It's something we'll probably have to go with Chemaxon. And if you were using Marvin Sketch Java Edition, there was a nice keyboard shortcut, period S6 and things like that to make it more easy for those folks that were doing substitution count there. And George, I'll send you an email and we can maybe send some examples to help solidify substitution versus substructure search so that you can get an idea of how that works. So I think that brings us to our 36 minutes. I apologize for going 6 minutes overboard. Send some more questions. Kim, if you want, I think we answered a lot of the questions here. But we'll hopefully make this recording available. If you find it useful, please recommend it. Send the link off to some of your friends, and then we hope to hold some more of these sessions later on in the year.
And we will, and thank you so much, Derek. That was a fantastic webinar, and I will get a link to the recording and to the slides out by this time tomorrow. And keep an eye out for invitations to more sessions, because we will have these frequently to make sure that everybody makes the transition smoothly. Thank you so much, and goodbye.